Yes. The next one. If x plus radical 2 equals negative x. How would you solve that? So you've got x's on both sides of your equation. You need to get your x's to the same side. So I would add by x. So x plus x is 2x. Huh? Oh, you moved that. You got negative 2x?
Yeah.
That's fine. Same thing. Same difference. Then subtract by radical 2, or I would move the radical 2 over and it would become negative. So 2x equals negative radical 2. It's not supposed to be hard yet, guys. It's supposed to be the... This is the without any trig in it. We're just doing algebra. Is everybody okay? Divide by 2. I'm just getting those nervous... I'm getting that nervous energy. So when I have x's on both sides, notice these x's were like terms, right? So get them together to combine them. Because we like to combine like terms. What about here? Can I combine like terms here? No. Okay, but I do have a single x. Can I solve and get that single x isolated? Not first.
Oh, you gotta move the 1 over.
Move the 1 over first. Then divide by 3. Then take a square root. So I chose to take a square root. I did that. So when I take a square root, plus or minus, radical 1/3. What's the square root of 1? What's the square root of 3? And because we're not in calculus yet, you can't leave that as your answer. Because there's a square root in the denominator. So you have to rationalize the denominator. So that's radical 3 over 3. Everybody okay with that? We'll put a radical 3 on top and bottom. So 4, we want to do the same thing. I want to get the x by itself. Well, I've got x's on the same side. That's what we have to do. Because I can't isolate an x because I have not like terms. So I can't combine the x's. So my next strategy becomes factoring. So I'd have to know, can I factor that? Well, it's a trinomial in the form of ax squared plus bx plus c. So I would do the a times c method. Oh, gosh. 2 times 1 is 1. I'm sorry. Oh, gosh. Now y'all got me confused. 2 times 1 is 2. What are the factors of 1 and 2? 1 times 2. So I can split up the b term. How can I make that be negative 1x? If I wrote it as negative 2x and positive 1x. Does that look familiar? A times C, maybe. Group and group. GCF is 2x. X minus 1. GCF is positive 1. X minus 1. Do the parentheses match? Yes, that means grouping worked. So this factors to be what's in front of the parentheses times the matching parentheses. So if 2x plus 1 times x minus 1. I'm sorry if you're watching this on video. I know it doesn't show up very well, but the purple shows up great in class. So my apologies. It's 2x plus 1 and x minus 1. Now I'm not finished. I have two things multiplied to be 0. So that means either The first parenthesis must be 0, or the second one must be 0. And we solve. So this is 2x equals -1, so x equals -1/2. Here we've got x equals 1. So I have two solutions. I have -1/2 and +1. Can you do 5? Try 5. Yes? No? No, no. A times C is 6. What multiplies to be 6? 1 times 6 or 2 times 3. Which of those can combine to be 5? Both of them. Okay? So you've got to pick the correct one. So how do you know which one needs to be correct? They have to have different signs because they have to multiply to be -2. So which of these have different signs combining to be 5? It would be 6 minus 1. So I need to rewrite this as 6 minus 1. So this is 3x squared plus 6x minus 1x minus 2. And then we group. GCF is 3x. That leaves me with x plus 2. GCF is -1. Leaves me with x plus 2. Parentheses match. That's good. That means grouping worked. Factors to be what's in front of the parentheses times the matching parentheses. And those multiply to be 0. So if two things multiply to be 0, then either the first thing is 0 or the second thing is 0. So this would be 3x equals 1, which means x has to equal 1/3. Here, x equals -2. Those are my solutions. I have 2 sine x minus 1. Can I solve that? Doing what? I need to isolate the sine of x. So I need to add 1. And now sine of x is being multiplied by 2, so I can divide by 2. That seems familiar. No, not yet, not yet. This is what we practiced on Friday, right? I do a little algebra to get to this point, but this is what we did that whole page on Friday. Sine of what angle equals 1/2? So I need to figure out, well, because it's a sine is in, because it's a sine and the argument is positive, sine is positive in the first and second quadrants. All students take calculus. So this could be in the first quadrant or in the second quadrant. Sine is a ratio of the opposite over the hypotenuse. Which means the missing side is radical 3. So that means the reference angle needs to be a 30-degree angle. So then the question is, how much did I rotate in total to get a 30-degree angle in the first quadrant? Yep, pi over 6. And then how much did I have to rotate to get a 30-degree angle in the second quadrant? Questions? What about example 2? I need to get all of my sine x's on the same side. So I could add sine x or just move it over, it becomes positive. So I have sine x plus sine x, which means I have 2 sine x. If I move the radical 2 over, it becomes a negative radical 2. Everybody's okay? Sine x is being multiplied by 2, so I can divide by 2. So now sine x equals negative radical 2 over 2. That looks familiar. You following what they're doing? Are you figuring out what they're doing? Oh, all right, okay. All right. I don't see anything else. Now, from this point, sine of what angle gives a negative ratio? Well, because the ratio is negative, I know it must be in either the third or fourth quadrants. Sine is a ratio of the opposite over the hypotenuse. So the opposite side's radical 2. The hypotenuse is 2. Which means the missing side has to be radical 2. Which lets me know my reference angle is a 45-degree reference angle. So then the question is, how much did I rotate to get a 45-degree reference angle in the third quadrant? 5 pi over 4. And how much did I rotate to get a 45-degree reference angle in the fourth quadrant? 7 pi over 4.